Now we're going to look at some Chapter 2 review. So you guys have the K form of the test. I'm going to look at the G form so that I'm not just straight up giving you answers. So when we look here in problems that just give you an ordered set of pairs, and we have to determine a relationship, I like to set up a table first. So I'm actually going to zoom in a little bit more on this so I have some more space to work. Can you see in number 6 what that relationship is going to be? How does every y value compare to the x value?
It's 1/3. I mean, no, it's 3 times.
3 times, right. So here, this one's a little bit easier. We could say y is 3x. That's pretty quick to identify. But if we look at one, I haven't even looked at these answers yet, so I might be getting into a dangerous situation. Let's look at one like 9. This looks interesting. So if I set up a table, because it helps my brain to look at the values like this. 0, 8, 1, 6, 2, 4, 3, 2, and 4, 0. So it helps my brain if I can just go down this column and say what's happening to the y. Well, every time I change, what happens to the y?
The y goes down by 2.
The y goes down by 2. So I know that y
and x goes up by 1.
is decreasing by 2 every time that the x moves forward. So if it's every time the x moves forward, I'm going to have that change multiply by the x, because every single x I have I take away, and then you said plus 8 because my intercept point when when x is 0, my y-intercept right there. So that one was, again, a little bit easier. I may just go ahead and solve the one that you're looking at. Let's try one more that might help you with the one that you're struggling on. So if I look at number 10. Let's do my XY table. Got a little close. -2 and a 16th. -1, a 4th. 0, 1, 1 and 4, and 2 and 16. So what do you see happening there to my y value? Every time I go up by an x, what happens to the y?
It's multiplied by 4.
It's multiplying by 4. So I'm always looking at, as my x changes, what's my y doing? Well, that is a times 4. And then I check, does it continue to work? Well, yeah, this continues to work for every one of them. So since it's times 4 for every x I move, I know that y is going to equal 4 times x, but I have to figure out, where do I start?
It's 4x plus 1.
Plus 1?
Because x is 0 by the time that y is 1.
So the only thing that we have to check then is when I plug in x being -2, this turns into 4 times -2, so -8 plus 1, that'd be -7. That doesn't give me 1/16. So that doesn't actually work out. Even though we see that the change that's happening to my y is it's multiplying by 4. We have our points in there, right? -2 and 1/16. How else? So that would work for like the positive. Well, that doesn't even work here, because if I plugged in my x is 1, 4 times 1, that would give me 5. So this isn't going to work out at all. So when multiplication doesn't work, start thinking about powers, like exponents. So is there a way that we could use exponents here? Because I know that any number to the 0 power is what? any number to the 0 power?
Is 1.
Is 1. So if I had a number here to the x power, then that would work for this point, right? Because if I had the 0 power, my output would be 1. But I figure out what would that base be?
4.
4. So let's try 4, because when x is 1, y is 4. So for that to work, well, now when x is the power of 1, does this work? Yes. When x is the power of 2, 4 squared, that works too. So let's go back to our negative numbers. Now, what does a negative power actually tell me to do? When I think about y being equal to 4 times negative 2,
It becomes a fraction.
what do you mean it becomes a fraction? It does something else too. I agree, but
I don't know how to phrase it exactly, but I know what it is, but I don't know how to phrase it.
so here's the weird, cool, whatever you want to say. When we have a negative exponent, what it tells me to do is look at my base as a fraction. So you were right to begin with. Then I flip it and I make my power positive. So this then becomes y equals 1 over 4 squared. What would 1 over 4 squared be?
1/16.
1/16, which works out. So this is my equation, for that relationship. So even when you can see a relationship times 4, the other way you can do times 4 is using 4 to a power. So because we saw that this was times 4, that's what indicates that 4 is the base in this equation. Does that kind of make sense?
Yes.
Because every time we move by an x, I need another power of 4 or another multiple of 4.
But wouldn't it need to be 4 to the power of x plus 1 because it intercepts the y at 1?
But remember, if my input x is 0, so my input x is 0, so x goes here. What's any number to the 0 power?
1.
1. I don't need to add 1, I'm at 1 already, because 4 to the 0 power gives me 1. So this works out. Does that make sense?
Yes.
Cool.